Hi, my name is Ms. Randa Zatari. I'm a high school chemistry teacher. This is my first tutorial video. I want to share with you a selected chemistry AP diagnostic test. As you know, AP tests are of two sections, section for multiple choice questions and section for written parts. I'm going to practice with you today some exercises of multiple choice as a diagnostic test. Yeah, it means that this information, you should know it. So let us practice. You will see me in this video solving in details. Yes, because I want you to know actually how to understand the problem, think of a problem to get into the correct result. Later on, when you practice a lot solving, you will find yourself so fast in solving AP problems. So let us start by the first problem, multiple choice. A solid sample of aluminum carbonate is strongly heated to drive off carbon dioxide, which is then bubbled into sodium hydroxide, forming sodium carbonate and water. How many moles of sodium hydroxide required to react completely with 0.6 moles of aluminum carbonate? In this problem, we have to know two things to solve it. First of all, I have to have idea about how metal carbonates, they decompose to give what products. This is first thing. Secondly, how to relate the reactions later on and solve according to stoichiometry. So this table is really very important, and you should be all understand and memorizing this table. This table is segregated according to reactivity of metals, because based on their reactivity, the products will be different. The first, potassium and sodium, they are of highly reactive metals. Calcium, magnesium, aluminium, zinc, iron, lead, copper, they are moderately reactive. And silver and gold, they are low reactive metals. What's interested for me here in this table is this one. I'm talking about aluminium. If they decompose, if I have aluminium carbonate decompose, I'm expecting metal oxide and carbon dioxide. So by this, I know how to write the equations. Please note that the nitrate ions, NO3 minus, carbonate, CO3 2 minus, and hydroxide, OH minus. Let me write the first equation. I have aluminium carbonate, solid, because it's decomposition, so solid. Upon thermal decomposition, it gives the corresponding metal oxide. The metal is aluminium, so aluminium oxide plus carbon dioxide. Definitely it needs balancing. Aluminium, so this is 3 because the aluminium is 3 plus. Okay, so here 3 carbon, so this is 3 carbon. Let us check the balancing. 2 aluminium, 3 carbon. 6, 9. Equation is balanced like this. The second equation, he said the carbon dioxide obtained bubbled into sodium hydroxide. When it is bubbled into sodium hydroxide, it gives the corresponding sodium carbonate and water. And the equation is balanced like this. Now, I have these two equations. This will help me in solving the problem. In the given, the number of mole of aluminium carbonate is equal to 0.6 moles, and asking about the number of moles of sodium hydroxide that they are required. Okay, the common in between these two equations is the carbon dioxide. So I have given of aluminium carbonate, and I want to find the moles of sodium hydroxide required. So the common in between them is carbon dioxide. So let me find the ratios in between these compounds in order to know how to calculate. So from equation A, I have aluminium carbonate to give 3 carbon dioxide. To find the ratio of moles, the first line always I use stoic, which is the ratio of the substances I have, and then the given and required. here we have 1 mole of aluminum carbonate corresponds to 3 moles of carbon dioxide. So if I have 0.6 moles, should corresponds to how many moles of carbon dioxide? By cross multiply, the number of mole of carbon dioxide will be 3 times 0.6 over 1, which is 1.8 moles. Like this, I found the number of moles of carbon dioxide that I can relate now to sodium hydroxide to find the requirement. From equation B, I have carbon dioxide and sodium hydroxide. Also, the first line, always I use stoichiometry, the ratio of the substances, and then requirement, given and requirement. And then given and requirement. So the first line is according to stoic. The second one is the given and the required. So here in the ratio, every 1 mole corresponds to 2 moles of sodium hydroxide. Every 1.8 moles, the moles I calculated from part A, from equation A, how many moles? Like this, I find the number of mole of sodium hydroxide to be 3.6 moles. And like this, I got what I wanted. So the answer, the best answer and the correct answer is 3.6. Now moving to number 2, a sample of sodium trichloride 0.1 moles explodes according to the following equation. He gave me the equation. What is the volume of the gaseous products assuming ideal behavior at 1 atmosphere and 273 Kelvin? As you see, when nitrogen trichloride explodes, it gives me a mixture of nitrogen and chlorine gas. So I need to find each volume alone and then to add them to find the total volume. So let us solve it. I have nitrogen. Definitely I will copy the equation using always stoichiometry. And it's given to me that the pressure, is 1 atmosphere. The temperature is 273 Kelvin. We know 273 Kelvin, it means 0 degrees Celsius. Based on the equation that we know, temperature in Kelvin is the temperature in degrees Celsius plus 273. So pressure 1 atmosphere and temperature is 0. It means we are talking about STP condition. In STP condition, the molar volume is always 22.4 dm cube or liter. Okay, let me find from the ratios. First of all, let me find the number of moles and relate them to volume. So the first line, as always, it's stoic. Second, given and require. Every 2 moles corresponds to 1 mole correspond to 3 moles. So it's given in the problem 0.1 moles of sodium trichloride. How many moles? I will cross multiply for each one aside in order to find the answer. For nitrogen, it's 0.1 moles times 1 over 2, which is equal 0.05 moles. Similarly, I will find the number of mole of chlorine, which is 0.1 times 3 over 2 by cross multiply. And the answer will be 0. moles, 150 moles. Okay. Now, I don't want moles, I need volumes, no problem. We know that the volume of any gas equal the number of mole of the gas over V molar. So let me substitute that of nitrogen. It's the number of mole of nitrogen in V molar at STP 22.4. So let me just substitute V of nitrogen equal 0.05 over 22.4. So 0.05 over 22.4. Wait, the volume of a number of mole of a gas. I'm sorry. Let me correct myself. The number of mole of any gas is the volume of gas over V molar. which means I will deal for nitrogen first of all. Number of mole of nitrogen is equal volume of nitrogen over 22.4, which is number of mole of nitrogen. I found it 0.05 equal volume of nitrogen over 22.4. So the answer for nitrogen 0.05 times 22.4, which is 1.12 dm cube or liter. Similarly, I will find for chlorine. So number of mole of chlorine is equal volume of chlorine over 22.4. Already I found number of mole of chlorine equal volume of chlorine over 22.4. By multiplying, the answer will be equal to 3.36 dm cube or liter. So the V total he's asking about is 1.12 plus 3.36, because he's asking about the total volume, which is 4.48 liter or dm cube. Like this, we found the answer, and the correct answer is this one. Now let us see number 3. In number 3, under which set of conditions will a sample of a gas deviate most from ideality? Okay, when we talk about gases in class, we talk about real gases and ideal gases. In ideal gases, they assumed nothing in reality is ideal, but they make assumptions for ideal gases. They said that particles have no volume, but in reality, particles, they do have volume. Collisions are elastic, no energy loss, while in reality, there is energy loss in collision. No interaction between particles, but in reality, there exist intermolecular forces between the real gases. When real gases behave like ideal gases, and why we use in calculation ideal gases? Because we live at low pressure and high temperature. So when the temperature is high and the pressure is low, we say that the real gases behave almost like ideal gases. This concept should be in our mind while solving number 3. Under which set of conditions will a sample of gas deviate most from ideality? We said that to behave like ideal should be high temperature, low pressure. So deviate most, it means the opposite. It means at low temperature and high pressure. So anything high temperature, I will cross it from my mind. So I'm left with these two options. What's the difference? The difference is in the other factor, which is the size of molecule. Now, we know that if the molecules, they have large sizes, it means the interaction between them is higher. The interaction between them is higher. While in the small molecules, it's the opposite. Okay, anyhow, in this problem, in both they have large, but the correct one is with low temperature and high pressure, so the answer is A. No, because this one is incorrect. Now, which of the following best explains why diamonds are hard and graphite is soft? To know, we know that diamond and graphite, both of them made up of only carbon. The only constituent of both diamond and graphite, only carbon, by the way. But it's because of how they are arranged, they have a huge difference in their properties. If we look at the carbon, as you see here, carbon, they are connected in a rigid way to each other, a tetrahedral form. And each carbon connected to another 4 carbons. This is part from a giant molecule, by the way. Diamonds, well, graphite, they are giant molecules. We are taking section here. Alternative on the graphite, we see the carbon connected to 3 carbons. 1, 2, 3. So carbon only connected to 3 carbons. There is free electron. And make plates in the graphite. And between the plates, there exist weak intermolecular forces. Weak intermolecular forces, which make them slide over each other. So here the forces are weak, so it makes the graphite soft. That's why they use it in in pencils, because it can slide easily, while here it's rigid. So the best answer that I can choose here is diamonds. They have interlinked crystalline layers, while graphite has flat planes of crystals. Now, we will continue in solving multiple choice questions. Number 5. Rubidium in reality, it's less electronegative, not more. It's less electronegative than lithium. The electron that is lost in order to form a stable rubidium ion. Why? The electron that is lost in order to form stable rubidium ion. Because rubidium, as we see in the periodic table, and lithium, they belong both to group 1. This is a lithium and this is rubidium. And to reach stability, it means to have the same electron configuration of corresponding noble gas. They should lose 1 electron. Here lithium 3, while corresponding helium is 2. So yes, it should lose 1 electron to reach stability. And similarly, all the elements in the group, because they are family. So also rubidium. Okay, so what about electronegativity here? Because he's talking about it. The electronegativity increases across the period and decreases down the group. Similarly, ionization energy, because he gave me option about ionization energy. Ionization energy increases across the period and decreases down the group. So if we have to compare between lithium and rubidium, lithium above the rubidium. So the electronegativity of lithium higher than rubidium. So similarly, the ionization energy of lithium higher than that of rubidium. So the best answer is it has a lower ionization energy. Right. Now, let us see number 6. Which of the following will dissolve in concentrated hydrochloric acid? Cu2O, this we call it cuprous oxide, or also we can call it copper 1. It has, so the ion here, copper ion, is +1. And it's red in color. This is cuprous oxide. What's this black? In reality, this is cupric oxide. So there is difference between cupric and cuprous. Cupric oxide is copper 2 when the oxidation number is Cu2+, unlike the one that we are talking about. Magnesium sulfate, this one is magnesium sulfate, white crystalline. Let us see what will happen, and an ACl. Let us see what will happen when we add to them concentrated hydrochloric acid. So in adding hydrochloric acid, cuprous oxide plus HCl aqueous, it gives me CuCl aqueous plus water. Okay. Oh, so cuprous oxide, it dissolves in HCl and reacts as well. Now let us see with the other one, magnesium sulfate. magnesium sulfate, if I add to it HCl, double replacement reaction like the first one, it will be magnesium chloride and sulfuric acid. Okay, so it dissolves also as well, it dissolves, right? So it dissolves as well, so it needs balancing. Okay, now what about NaCl? Also NaCl, if it's solid and I add to it HCl, it will dissolve. But what happens here? NaCl has Cl minus, here Cl minus, so there is common ion effect. So it will dissolve, but little bit of it will remain as a solid part, but we consider it dissolving. So the best answer for number 6, that all of them upon the addition, they will dissolve. Now let us see number 7. Ozone reacts with ammonia according to the following overall reaction. If the decomposition of ozone shown below, this one, O3 to give O2 plus O, is the slowest step. Slowest step has a meaning in kinetics. In kinetics, when I say slowest step, it means this is the rate determining step. It means it's the step that controls the reaction. So the decomposition of ozone controls the rate of the reaction. Now the question, how the reaction rate change if the pressure of ammonia is doubled? In reality, nothing will happen, because ammonia, it's not the one that controls the reaction. The decomposition of ozone is the one that controls the reaction. Okay, now number 8, what is the pH of a solution made by combining 5 milli of 0.03 molar sodium hydroxide and 5 milli of 0.01 molar phosphoric acid? No calculations required for pH, but we have to do some calculation to see what will be the answer, the solution, what will be the substance that it is obtained. In order to figure out, I have NaOH 5 milli and 0.03 molar and combined to phosphoric acid with 5 milli as well, and concentration 0.01 molar. So let me write the equation of the reaction, because stoichiometry always, as usually, it matters. Always, as usually, it matters. So to give sodium phosphate plus water, and definitely it needs balancing. Now it's balanced. Okay, let me see what will happen upon they react. Here, the number of mole, I can calculate it in millimole, no problem. 0.03 multiplied by 5, which is 0.15 millimole. Definitely based on the fact that you know C equal N over V, which means N is C times V, don't forget. So I multiply. So when I multiply, that will be 0.01 times 5, which is 0.05. Now let me see how the reaction will proceed. I, it's for the initial quantity, to see if there is excess or limiting. I have to check everything. So I stands for initial, C change by reaction, the amount reacted, and the R here, it's the remaining quantity. Okay, the initial quantity is 3, and the initial quantity is the one that I calculated already here. I'm not talking about the stoichiometry. I'm talking about the initial quantity that I am adding. Okay, so the initial for sodium hydroxide, 0.15 millimole, and here 0.05. The quantity which is lower, it's the one which is limiting. But here I need to pay attention, change by reaction is subjected to stoichiometry. So this will be minus 0.05 times 3 and minus 0.05. So that will be 0, 0. So the substance obtained after I combine these two, the obtained one is sodium phosphate. Let us study its nature. Sodium phosphate, it's made up, it's a salt coming from a base, which is sodium hydroxide, NaOH, which is strong, and from a weak acid, which is phosphoric acid, So if I have to look here, always the nature of the salt follows the nature of the strong parent, if I can call the acid and the base parents. So the strong, its nature is base. So sodium phosphate, it is base. Its nature is base. Now I want to choose the best fit answer. It is base, but it's weakly basic. Why? Because strongly basics, when I say strong bases goes for sodium hydroxide, potassium hydroxide, magnesium hydroxide, okay. But weakly bases are the bases of the salts. Okay, hopefully that you enjoyed the lesson and you understood very well all the details. In the next video, we will continue solving in diagnostic test multiple choice questions. Thank you very much.